In this video, we're going to learn how to do a test of significance for one proportion on the Nspire. So I've taken this problem from page 559 or 9.2.2 in the ebook about potatoes. The potato chip manufacturer has just received a truckload of potatoes from its main supplier. Recall that if the producer finds convincing evidence that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load from the supplier. A supervisor selects a random sample of 500 potatoes from the truck. An inspection reveals that 47 of the potatoes have blemishes. Carry out a significance test at the alpha equals 5% significance level. What should the producer conclude? So we want to perform a test where the null hypothesis is that the proportion of blemished potatoes is 8%, but our alternative that we're trying to find evidence for is that the proportion is greater than 8%, where P is the actual proportion of potatoes. We check the conditions and so forth, and they're all met, so I'm not going to go through that part of it, but I want to look at how you do this on the calculator. So we go to Menu and Statistics and Stat Tests, and we go to a one proportion z-test. Now here we put our number of successes in this case, first of all we put in our null hypothesis value. So that P0 is the null hypothesis proportion. So this would be 0.08. And then the number of successes in our sample, we got 47 blemished potatoes out of 500. Then we choose our alternate hypothesis. In this case, our alternate hypothesis is a greater than hypothesis. And then push OK. And so notice what this gives me. This gives me the title of the test. It gives me my alternate hypothesis. It gives me the z-test statistic. In other words, this tells me that p hat, which is right here, p hat is 0.094. That is about 1.15 standard deviations above the mean of the model, which is at 0.08. The p-value is 12.4%, and then it gives us our n. So based on this p-value, at the alpha is 5% level, we do not have convincing evidence. Since p is greater than alpha, we do not have convincing evidence in support of our alternate hypothesis. We fail to reject the null hypothesis. We cannot conclude that there are more than 8% blemished potatoes. Okay, so this is not far enough away, far enough above 8% to be convincing evidence. It could just be sampling variation. So 12% of the time we're going to get a random sample out of a truck with 8% blemishes that has 9.4% blemishes just by random chance. So we cannot reject the null hypothesis. So we go back and just look here at the sample problem in the book. Okay, so notice that 1.15 is come from taking p hat minus p divided by the standard deviation of p hat, which is the 0.8.92 divided by 500. That's where you get the test statistic that's given to you in the calculator printout. And then if we look at the area under the standard normal curve here, is 1.15 standard deviations above the mean. That area, that is our p-value. So doing that with technology allows us to quickly get our p-value and our test statistic. Now, what sort of work should be shown? Well, you still want to show the calculation using the correct formula, but you just have a way to check it and do it more quickly now.